This material is made available to you by or on behalf of the University of Melbourne under Section 113P of the Copyright Act 1968. It may be subject to copyright. For more information, visit the University Copyright website.
Okay, welcome again on another lecture of construction history. With this one we'll talk about glass. We are now in the third module of the subject, and we are talking about the origin of the industrial culture that still prevails today, and the period in history that is normally known as the Industrial Revolution. Now, the glass industry, it is probably one of the sectors of the construction industry that anticipated the efforts, the mechanisms, the complexity, and the international networks that are normally characteristic of an industrial society. So with this one, even if we describe today glazing methods and systems of production that are to some extent even antecedent the Industrial Revolution, we will discover how these are actually in a way anticipating some of the things that will become dominant, particularly in the 1800s, and then also after that in the modern age. So we'll go through some typical methods of manufacturing of glass that most of which are have disappeared because they were somehow still related to a considerable input from manual labor. And in this process we will also discover how glass could be produced in different ways, and we will see how some of these methods somehow set the scene for the technological developments, that they became more dominant and more applicable for very large scale production. So obviously glass has a very, very long history, like most of the materials that we still use in construction today. Its origins trace back to the ancient times. Especially we know for a fact that glass was produced to significant scale and with a considerable level of sophistication during Roman times. Now the Romans themselves were not quite the masters of the trade. The actual origin or the invention of the glass, if you wish, is most of the time ascribed actually to the Syrians and sometimes mistakenly also to the Phoenicians, for which there are some anecdotal stories that go back to the time of Pliny, according to which the Phoenicians almost discovered glass by accident by lighting a fire with some soda blocks, and then the mix of soda and sand eventually created glass. Now that's obviously a myth. The reality is that in order to produce glass, some enormous temperatures are necessary that are not achievable with a normal campfire. But nonetheless, the myth of this accidental discovery by the Phoenicians somehow respects some truth. The fact that glass was developed first in the Middle East, not exactly in ancient Lebanon, but more in Syria. And the glass most likely was discovered accidentally, most likely though as a result of processes that were probably related to terracotta or to creation of earthenware more than just lighting up a campfire. Glass also related to the necessity to have abundant resources of wood in particular, which again strengthens the idea that glass may have originated from those parts of the Middle East where timber was available. So not far from Lebanon and therefore in Syria again. So the Romans therefore borrowed this technology and they brought it over in in the middle of Europe. And we do have a series of artifacts that still survive, like these glasses or this glass amphorae, which were used for drinking. So drinking cups that we still recognize and we use today, as you can see. And you will probably realize as well the remarkable properties of glass as a material that is virtually, if not immune from defects, almost virtually destined to last forever. So the first method of glass that we'll discuss today is the so-called blown glass. And I will introduce this more broadly first by looking, before we get into the specifics of window glass, or glass used for construction. I will just want to clarify a bit on the method of production of blown glass. Now, glass, as I said, needs to have extreme temperatures in order to be produced. So these temperatures are required in order to have to reduce to a semi-crystalline and liquid consistency, although still fairly viscous consistency, of the key ingredients of glass, which are sand, lime, and soda. And the problem with glass making is that in order to have these ingredients to somehow mix together and combine together to create glass, it is necessary to reach temperature that are approximately around 1500 Celsius degrees. Now, that is a very, very high temperature, that it's usually beyond the capacity of any normal oven, for example. And so in due course, glass making was really reliant on the ability to create to have two things. First of all, the availability of enormous amount of energy, which in the past was mostly wood, and secondly, the ability to control the temperature during the melting process, so that there would be, of course, the best, most efficient use of the resources available, which were considerable, and also the ability to maintain the temperature at a certain level for a prolonged period of time. So then these furnaces would have to be such that glass was able to be extracted and worked, and we will see how in a minute. So the traditional furnaces that were used in the past, certainly through the Middle Ages, most likely also in ancient times, are the ones represented in this picture here, in a treatise on metalworking, actually, the so-called the Re Metallica, written by Georg Agricola in the Renaissance times. And this is the type of oven that would have been very common, for example, in Venice being one of the major centers of glass making in Europe. Again, due to the fact that Venice had, as we know, many rich and prolific contacts with the East, and again, from through the eastern part of the Mediterranean, then to the areas where the art and the trade of glass was most developed, again, Syria. So these furnaces were obviously fed by wood fire that would normally go at the bottom of the furnace, and then there would be a number of pots, typically of clay pots in terracotta, that would be filled with ingredients of glass. Then the temperature arising from the furnace and the burning chamber below would lead these pots to a temperature that was sufficient to melt ingredients into a consistency that was molten glass. The top of the furnace was also used to recover some of this heat, and as an annealing chamber. So once glass is produced, it's important that it's also put in a period of seasoning, almost, that reduces the amount of superficial stresses and makes glass more durable and more prone to be worked and cut. Now, in time, these furnaces develop further without necessarily entering the industrial furnaces that will be discussed later on in the next module. The necessity to optimize the amount of energy available has led to some developments that introduce, for example, the ability to recycle some of this heat from the furnaces by having, for example, like in this case, a conduit on the side that would give you a more controllable flow of temperature that was feeding the annealing chamber. And on top of that, in this particular wood-fired furnace, we see also how the heat coming from the annealing chamber was recovered itself by feeding or by giving a base that was obviously hot to provide a milder temperature required to dry the wood that then was fed at the base of the furnace here. And then you can see how here there's a process where you have the melting pots here on top. There's an opening on the furnace from which glassmakers can gather what they call as the metal, which is molten glass. Then the wood will be fed here below this stone grate. This incredible temperature will be above this grate, and then the ashes will still, and the embers will fall down, still somehow refeeding heat into it, and then a draft of air will be drawn through to somehow continue to push the fire to very, very strong and very powerful flames that could almost ignite the ingredients into their glass consistency. And again, as we said, then this heat was recovered to create to somehow make the best out of that expensive energy. To give you an idea, in the past, most of the furnaces were wood fire. At some point, coal was introduced, and then later on gas. But when wood was used to produce glass, normally it would be required to have 4 kilograms of wood in order to produce 1 kilogram of glass. And this meant that very often these glass centers were somehow nomadic, and they created significant outcomes of deforestation in some parts of Europe that actually became quite problematic, and then eventually led to the abandonment of these wood-fired furnaces. So I'll just quickly now take you through what is blown glass and why is it something we need to be aware of. Now, blown glass is still used today for decorative purposes. It's not necessarily used for commercial purposes. It's certainly not used for the production of window glass, but blown glass still survives as an art, as a craft. And what I'll show you next is a demonstration that I was able to attend when I visited one of the glass museums in the United States, in Toledo, Ohio. And Toledo being one of the most important centers of the production of glass in the United States, right through the 1900s. So blown glass, again, usually works in this way. You have a series of pipes here, you can see in metal, or punts that are not necessarily able to have, that are not necessarily able to feed air through a hole, like in this case. So you can see a hole here through which glassmakers are able to blow through the pipe, and then punts that can be used simply to pick up the glass and spin it or work it. So normally the process implies that there is a furnace. In this case, the furnace is not wood fired, but it's a smaller furnace used for blowing glass. So it's not the same furnace you'll find in a glass production line today for glass for commercial construction purposes. And the glass is captured by having a punt or a pipe, and it's sort of gathered into this lump that you can see. It's glowing there. Then this lump is connected, of course, to the pipe in this case, you can see, and this can be worked by spinning it, by using some tools. So the material it has a very interesting consistency. It's almost solid, but it's in virtue of the application of forces with forceps or other tools. It's able to be shaped and transformed and in its morphology. Then the glass can be, once it's touched to a pipe, it can be blown. So just a very brief spit of air through the pipe. Once it reaches the other side of the pipe, just a minimal amount of air that would enter the globe of the lamp of glass produced will expand as a result of the heat that it's contained within the globe, and push out further the lamp of glass. Then the glass can also be fed into molds, like in this case, that can be used to give it another shape. In this case, it's sort of like a conical shape that has been sort of it's kind of like a sectional star, and then this star is sort of pushed against a steel table onto which, with rotation and some pressure, this initial mold can be twisted, and then again by blowing further inside the pipe, the glass can grow, and then eventually again can be worked out to any not any shape we like, but certainly to many different shapes that are available, and ultimately it can be worked into a piece of art like this. Now this is a bottle, and now the method of glass blowing, as we said, it's not the one we use for windows today, but it is a system that was used for many years to produce sheets of glass or expensive glass that were flat, and then it could be used then to produce glass. So there are two main methods of blowing glass that were used in the past, and the first one is crown glazing, and the second one is the cylinder glazing. Now there are both methods in which, again, the procedure starts more or less like what we saw before. A lump of glass that it's molten is attached to a pipe, and then progressively this is reduced into a sphere or a pear, and then by spinning or swinging or combining the action of, again, blowing inside the glass with opening up the surface, it is this lamp is expanded first and then reduced to a planar surface. So let's go through more in detail about these two methods, starting with the crown glass. Now, crown glass implies, of course, a lot of skill. Crown glass is a method of production that was most likely developed again by the Syrians, perhaps even during Roman times. It is quite possible, though we are not certain. But crown glass was certainly used in Venice. And crown glass became also quite popular and diffused in some parts of Northern Europe, in Normandy in particular. And then from Normandy it reached England, where the term, in fact, crown glass was used for the first time. Now, crown glass, it's a term that was introduced because one glazing manufacturer in England used to emboss the center of the glazing panels that was produced with this method, with a crown, so that the terminology somehow still stick together to this date. Now, the system was very simple in intent. So the lump of glass would be extracted from the furnace, it would be gathered, and then it would be spun to transform itself into a disc. And then this disc would be cooled down and then eventually cut to pieces to be used for window panes. Now, this is easily said. However, the process requires a considerable skill, and very often glazing manufacturers had in place a chain of trades or specialists within the glass house, each one of which was allocated a very specific task. So you can see here there is someone that is gathering the what glazers used to call the metal, which is the molten glass, and attaching it to a pipe. And then you can see there are other specialists that are blowing, reducing this initial spherical lump of glass into a pear-shaped or a globe of glass that it's hollow inside. And then eventually this would be detached from the pipe and attached to what is known as a punty, and you can see the process here where this exchange is happening, and then ultimately then it would be spun by using centrifugal force into a disc of glass. So this is the process explained with diagrams that takes us a bit more into the detail of how it's happening. You can see you have to read this diagram here from left to right and from top down. So you can see here the initial stage where the glass is gathered, is blown first into almost like a pear-shaped sort of vessel, and then it is worked on the table like what we saw in those pictures before, elongated, and then eventually it's sort of in this point here, it's sort of put onto two arms from which it is detached at one point. Sorry, it continues to be attached to a pipe on one side, but another element is attached to it on the other side. And then eventually at some point the pipe is removed and the panty is attached on the other end, until we get this sort of almost spherical or semi-spherical surface that is then open up into this shape, and then eventually the centrifugal force spin it further and transform it into a disc. So here's again the process illustrated by Diderot in the famous Encyclopédie in the mid-1700s. So this is a French publication showing again Normandy being of course in France, but showing the European diffusion of the method. And again we can see here how this is the point where the glass is opened from a sphere into a conical surface in this case, almost like a bell-shaped profile that is opened up and further by spinning. And one of the characteristics of crown glass was the fact that it was quite shiny, because during the process, at any point of the manufacturing, the glass would never touch any other surface. And in this process also, whilst being spun, was also fed into a furnace in which it was somehow polished by the effect of the flames and the fire. And so this resulted into a fairly shiny appearance that was quite characteristic and appealing as well. And then eventually with the centrifugal force, the glazier were able to spin it further, transforming it into a circular disc, that it's flat, that it has a certain inconsistency about its thickness, but that it's roughly of the same thickness throughout. But it is still attached to a point here to the panty, which obviously would leave a permanent mark. And you can see here some pictures how the system was still used. These are pictures from the early 1900s where the art of crown glazing was still used in some areas of England, mostly for reconstructing old windows, and at some point crown glazing was actually still used to produce lenses and for microscopes, even up until the 1950s. So here you can see the final step of crown glazing. This is a disc that is probably in the order of maybe a meter wide, which was probably one of the most common sizes. So some crown glazing discs could have been from 200 to 300 millimeter up until 1.5 meters, but that being probably the very maximum size available. Obviously glass is actually very heavy, even if it doesn't look so, and so this process required an enormous strength, and certainly also it privileged people who were taller rather than shorter in order to be able to work it out. Hence probably the success of this technique in Normandy. And you can see, however, how in the middle of a crown glass there is this bullseye, which is going to stay there forever, and it will have to be somehow eliminated, as we will see. And you can see here another stage of the process before the glass is reduced into this beautiful, very crystalline disc, where the glazier is working out into at an intermediate stage between a spherical lump that was extracted from the furnace and to something that more of a bell-shaped profile, and he's sort of helping himself here with some tools to ensure, whilst the glass is still spun, there's a certain consistency of shape that can eventually lead to this flattened cylinder. So this will be the result with the so-called the crown glass plates, or crown tables as they were known, would have to be cut into pieces. You can see here in the middle the bullseye, or that was the point where the punty would be attached to the glass. Then each one of these crown tables, as they were called, they would be split roughly in half and reduced into a series of smaller panes of glass that could be used for window making. Obviously, there was an inevitable amount of wastage implicit in the process, where it was somehow difficult to maximize. Hence, some guidelines here where, depending on the sizes of the crown table produced, there could have been a certain pattern or sequence of conversion that will be more productive than others. And these are some examples, most likely, of crown glazing still surviving. Certainly this is crown glass. You can see here a typical bullion type of window, which is a series of discs of glass, which are in fact the discs at which the punty of that used to spin the glass was attached to. So if you look closely there, you'll find there's a little bit of a dent in the glass that was the point where the center of a crown table with which it was spun. And here you can see closely how the glass, because somehow was not perfectly clear, but sort of had this impurities. And sometimes you can recognize a crown glazing because you would see that there is a tendency to have some radial or circular kind of marks that have been left into the surface of the glass. You can see some of these here. Okay, and again, this is certainly blown glass that was reduced into smaller pieces and then attached into glazed with lead in order to reassemble itself into a larger piece of architecture in this case, and window. Now you can't really look through it to see glass to somehow see. You can see there's plenty of optical distortions, but at the same time there's sort of shiny, almost crystalline characteristic of crown glass, which is quite pleasant to look at. So crown glazing was certainly, as I said, one of the oldest methods. However, it was not necessarily the oldest method and most popular method of production of blown glass. Another method that is probably more diffused to some extent, but also more influential in the sense that it led to developments for larger pieces of glass that are closer to the glass that we produce today. Was known as this method was known as broad or sheet glass, or sheet glazing, or cylinder glass. Now these are all equivalent synonyms that you might find somehow confusing. But sheet glazing, it's really a term that was used in the past, whereas today you might want to probably avoid that term because people might not understand what it was. But the process that we're describing here is still blown glass, where the first steps of the process are very similar to the ones of crown, where glass is gathered from the furnace, it is blown, but instead of being blown to a sphere that is then opened up, cut, or reduced to a disc, the glass is blown into a cylindrical shape that is then cut along its length. And you can see here that the operation with cutting is happening. And then this cylinder is opened up and into a larger sheet than crown glass, and then is used for window panels that can be a bit bigger, obviously, or fairly larger than crown glazing. So here I see again from Diderot in his Encyclopédie, we find the alternative of broad glazing, right? So it's larger glass, but again produced by attaching a lump of molten glass to a pipe and then progressively reducing this lump into a pear-shaped profile that is then open at one end. You can see here where they use some pinches there to reduce, to open up the cavity of the blown glass, and then the pipe is detached, and then the process continues by introducing a cut and then eventually spreading out this cut, and this is the final result. A piece of glass that it's almost flat. It's actually not quite flat. It's sort of, it normally has a bit of a curvature that would actually create some problems sometimes. And again, here are some other techniques of the method. You can see how glass has been blown into this sort of pairs, and then here you can see people swinging and reducing these cylinders into much longer shapes than the one we saw in the diagram before. In this case, you'll find there are some pits here which were used in fact to allow for these larger cylinders to be swung. And again, here is another summary of the same process, and you can find in this case the cylinder is also shaped or temporarily put into this table here, into which it is cut on its surface, on its top surface, along one line that it's running for the length of the cylinder, and then it's opened up further. Now, obviously, each different steps that is shown here would change depending on the particular technique that would have been developed, but the process is ultimately the same. I mean, the techniques may have varied from regions to regions, but normally, glass being a very difficult trade, these techniques would have been passed from generation to generation, and very often acquire a certain a local flair that could have created some variations on the procedure, and also some variations on the actual quality of the final product and the size. Now, the masters of this method of production, again, were the French. However, the mastery of cylinder glazing became renowned because of its application in a building that we'll discover soon in the next presentation, which is the Crystal Palace of London, that was used for the famous exhibition in London in 1851. Now, the cylinder glaze used for the Crystal Palace was produced in England. However, the factory that produced it, the Chance brothers, borrowed the technique by recurring to the expertise that was coming from France, in effect. And however, the Chance brothers improved the system by turning it into a proto-industrial method of production that was, if not already industrial method of production, that was still reliant on the skill of manual labor and the art and the craft of glass making, but that was able to produce fairly efficient large quantities of glass, and also sizes of glass panels that were certainly much bigger than the crown glazing that we saw before, but also much bigger than other cylinder products that were available at that time in Europe. And so this is the factory of the Chance brothers, one of the two factories, in this one in Birmingham, one of the suburbs of Birmingham, known as Methwick, where the Chance brothers became one of the main manufacturers of glass, certainly in the 1800s, but somehow found a bit of a decline in the 1900s for their inability to keep up with some other innovations that were to do more with mechanical systems of production. And again, this is in fact a picture that still represents how the glass cylinder glazing was produced. In this case, probably a picture of the early 1900s, where it was still used, or at least in this probably used this for demonstration purposes. And you can see here how, with the aid of some machinery, the glass is spun and swung in these pits, so it's sort of moving back and forth inside these pits by using this apparatus there, and this swinging movement elongates the cylinder to become fairly long and therefore able to produce a larger piece of glass. Again, this is a summary of the production of cylinder process. So you can see here the first step where the metal is gathered, and then it's eventually blown first into a sphere and then into this sort of pear-shaped vessel, and that is then forced into what's called a marver that gives it a certain shape that becomes more a certain shape that is determined based on the experience of the glassmaker, so that it becomes easier to work and transformed into a cylinder. So you can see here with the effect of the marver and the actual blowing inside a pipe that this shape of glass starting to take a certain size and a certain shape. Then subsequently this shape is reduced into an elongated cylinder here, almost like a missile shape here, but it's still attached to a punty or a pipe, and then it's swinging within this pit. Now obviously this is a very heavy piece of glass. It starts to become problematic to handle, and therefore here the Chance brothers introduced some machinery that helped to use to support the glass, but also to swing it inside the pits. And you can see here the point where once the glass is being swung into a decent shape, someone here with an hot rod is opening the cylinder at one end, and then the cylinder again is swung further, so the swinging will open up this hole further, and then eventually this is the final result. So you have perfect cylinders of glass that are available, that are cut. In this case below is using another hot iron or a diamond, and then finally the cylinder is fed into an oven where it is reheated, and in this reheating process that it's not annealing, it's a reheating that is specifically introduced to reduce this cylinder into a wavy sheet that is not quite flat. And so once the heat is somehow engaged with the glass is not melting again, but it's sort of relaxing. It is being cut already, and therefore it opens up and flattens itself, or almost flattens itself on a surface. The surface normally being another piece of glass. Then the glass will be extracted, even if wavy but still fairly warm, will be flattened further into something that will be quite close to a flat surface. Okay, so we saw blown glazing, and we saw that the two main traditions there of crown glazing and cylinder glazing, with crown glazing being more prone to using smaller elements with that kind of shining appeal and crystalline appearance. Cylinder glazing perhaps a bit rougher due to the fact that it has to get in contact with surfaces inside the oven that are necessary to flatten it, but allows to achieve larger pieces of glass. Now there's a third method that is very important, that was not used initially so much for window glass, but that was used more for other purposes. But this method of production, first of all, does not imply necessarily blowing, and secondly, it is important because it somehow sets the scene for the glass that we use today. So the system is known as cast or running plate glass. Now the term plate glass will become more important, more relevant when we speak about modern glass. Not contemporary glass, but certainly modern glass up until the 1950s. And this method somehow anticipates the production of plate glass. So it consists in the casting of glass onto a tray that is rectangular, that has a certain depth that is determined by by the glaziers, and then subsequently, once the glass is cast directly, when molten onto this plate, the glass is rolled with a heavy cylinder that puts pressure on it and reduced to a fairly consistent thickness, not necessarily perfectly flat or parallel, but a rectangular shape that then can be used to be polished, for example, or grinded to reduce glass, the surfaces of glass, to two perfectly parallel surfaces that can allow to have the maximum visibility through it. So now you're probably guessing what's the purpose of this. Mirrors, unlike glazing used in window panes in the past, always, by necessity, require to have perfect visual consistency, right? So now glass transmits light, but glass also distorts light, in particular if the two surfaces of a glass panel are not parallel to each other. So the methods that we saw before, for obvious reasons of manufacturing, were never able to achieve surfaces that were perfectly parallel to each other. Crown glazing was fairly clear, but not clear to the point that you could look through it and see exactly what's on the other side. As we saw some examples, in fact, of those lead panes in some buildings in France, for example, or many other buildings in England you will still see today. Cylinder glazing produced fairly rectangular shapes, but it was not a good surface, because in the process it had to get in contact when hot on surfaces that were not necessarily free from impurities. So even cylinder glazing was not necessarily a perfectly clear piece of glass, generally speaking. And now plate glass, on the other hand, allowed to achieve something that, when cast in the first place, may have not been perfectly transparent, but with another process known as polishing, which we see represented here on the right, then it was possible to reduce the two surfaces to two perfectly parallel faces that would allow light to transmit itself either in a crystal clear way or by putting some metal coating at the back, into transforming themselves into a very good mirror. So this technique was used of plate casting was used in the past also for decorative purposes. You can see here a Venetian mirror that was obtained not necessarily with the technique we described before, but just to show that the necessity to produce mirrors had a long history in Europe, and hence the necessity to produce even larger and better mirrors became an issue of demand in society, particularly in aristocratic societies. And you can see here some of the techniques also used for the creation of this medallion, which was created by an artist known as Bernardo Perrotto of Italian origin, but in fact a person who apparently somehow introduced this technique in France in the 1600s, although it's not quite clear if it was really whole his idea. Perhaps there was other local Frenchmen who contributed just as much as he did. Now Perrotto and others initiated this technique of casting glass to a larger scale, to a point that the French king took some interest in that, and particularly Colbert, the minister of finance, or the treasurer of those days for the French monarchy, took a considerable interest in the production of glass with these methods, particularly for the production of mirrors and glass of large plates, to the point that the king of France eventually gave a monopoly for the production of glass to a company which is very much the same company that is linked today to the company of Saint-Gobain, that still exists in France, but as a multinational corporation in production of glass and many other products today. So the production of glass with this method became almost like a national affair in France, and was certainly encouraged further by the production of and the need and demand for high quality mirrors that until then were always pretty much monopolized by the skills of Venetians. So the French were able to actually steal some of these skills of glass making from the Venetians, then went on their own account to the point that they became much more competitive, in fact, than the Venetians, and somehow took over in the production of glass, shifting the center of gravity of production of glass from southern Europe, Italy, and the eastern influences that go back as far as the Romans with Syria. Suddenly the epicenter of production of glass becomes northwestern Europe, in particular France, then Belgium, and then England will become the most important producers of glass. With these larger methods, they were able to achieve sheets of glass that were not available with any of the other previous methods. So you can see here the process where first the glass is casted, then it's reduced to a fairly consistent sheet, and then it is annealed soon after to ensure that stresses on the faces of glass are distributed evenly so that glass can be worked further, and then eventually extracted from the annealing layer with some certainty that it will not break, and then taken to a polishing chamber, a polishing workshop that could have been not in the same factory where the glass was produced, but also somewhere else, because glass production, as we said, was reliant on the availability of wood or the availability of infrastructure like rivers that would allow to transport the final product, let alone also the availability of good sand to produce the glass. But suddenly now with this method that breaks the production in two steps. First, the production of glass itself by casting, and secondly, by having glass polished, or potentially in another site or in another location, we start to see how the specialization of glass becomes very similar to the way in which we produce glass today. We do have today, for example, many plants that produce the ribbons of glass, but then there's very often separate plants that specialize in the lamination, the toughening, the heat strengthening, or any sort of form of post-processing of glass itself. They become more specialist, and they can be handled also from a supply chain point of view more efficiently. Now, and this is another picture that shows how plate glass was produced. In this case, in the United States of America, now we're starting to reach into the late 1800s. And we can see here again how the molten glass is poured into this very large cast iron plate. And you can see here that there's obviously an overhead crane that is taking care of that, assisting here the workers in the operation, still relying on a significant input of manual labor, proximity with glass, that it's very, very hot. And then again here, this glass reduced to a very large surface that will be flattened further by using this massive roller. So I will stop here on this story on glass, because the story is by all means not finished. We will come back on this when we speak about modern glass, but this was somehow a necessary preamble that we'll see how it continues further, particularly by having developments in plate glass that will become much more significant for the ability to control larger sizes, and also for the inevitable introduction of very or more efficient methods of production that are mechanical rather than reliant on the skill of human beings. But before we do that, we'll go back on glass to discuss some of the application of the systems we saw today, and in particular how cylinder glaze was used in the Crystal Palace. So until then, keep an eye on the LMS, and you'll hear from me next time.